Solving rational equations. A rational expression is a fraction where both the numerator and denominator are polynomial expressions. Okay? And then a rational equation is an equation. Equations have equals in them, by the way. An equation containing at least one rational expression. Sometimes they have many rational expressions. When you have rational equations, you always need to remember that there are restrictions if there are any x's variables in the bottom or denominator. For more information on these restrictions, watch my video, Rational Expressions Restrictions, because we're actually going to find them in this video. If you are given a rational equation, you always find the restrictions before you solve the equation. That's super important. Find the restrictions first, then solve the equation. When you solve rational equations, you factor all the denominators and find the LCD. Okay, I started to put just find the LCD, but part of finding the LCD is factoring all of your denominators. Okay, so I went ahead and just put that there, even though it's really the same step. Find the restrictions by setting each unique factor of the LCD not equal to 0 and solve. Again, because the LCD is a denominator, I put not equals. A lot of teachers put equals. Just do whatever your teacher does. That's fine. I put not equals to remind me that it cannot be that I'm restricting that value or those values. All right. And then my third step and my fourth step are going to be a little different than most. I'm going to multiply every term on both sides of the equation by the LCD. Then I'm going to simplify, and this step should result in the termination of fractions in the problem, okay? So while you're working the problem, if you do my step 3, you're going to immediately eliminate every fraction in the problem, and that ought to get a glory hallelujah, okay? Because nobody I know likes fractions. If you say you do, you're probably lying, trying to brown nose with the teacher or something. Solve the resulting equation accordingly, and what I mean is if it's linear, get every, x's on one side, numbers on the other. If it's quadratic, factor it or do the quadratic formula. If it's cubic, you may have to involve other things to do. I mean, it could get really hard. Okay, but solve it accordingly to whatever kind of equation is. Let me say more about my step 3 above. All right, and I told you it was not the same sometimes. The proper order of things goes something like this. You get both sides of the equation over the same LCD as we found above. Okay, what I'm talking about is this LCD right here. We get everything on both sides over that, and then now that you have two fractions that have identical denominators and they are equal, you can set the numerators equal. All right, so now I've just given you several steps here, and then this results in the same equation that I get in my step 4, okay? So I'm skipping a few steps here, and it only sounds like a few steps, but if you're talking about getting every term on both sides as a big LCD, if you have 3 or 4 fractions on one side and 2 or 3 on the other, you're talking about getting 5 LCDs. I'm skipping that all together. I'm multiplying by the LCD on every term, which might be a long step, but it eliminates fractions in one step. And I've never met anybody who didn't like to get rid of fractions in one step. All right? So, look, I am skipping some steps that generally create issues for students. Not the steps I skip. I'm saying if the students try those steps, it creates issues for those students because they're just long and cumbersome steps. All right? So I simply go straight to the non-rational equation, meaning I get rid of the fractions in one step without actually making all my fractions have the same denominator. I'm using the same denominator to get rid of them. You with me? But I've already found my restrictions. Okay? I already found my restrictions. See, I factor my denominators, find my LCD, and then I find my restrictions here before I go to multiply everything back. Okay? So, let's work some of these. And notice I've given you a box here to put your answers for the restrictions, and then a box here to put your answer for the problem in. Okay? So here, x over 3 equals x over 4 plus 1. So if I look at this, first off, find my LCD. Can I factor either one of those? No, I mean, if you want to say you can prime factor 4, but I mean, look, 3 and 4. So what's my LCD? Well, if it's just numbers, 3 and 4 are going to give me 12. And how do I find it when it's numbers? I start with the largest number, 4. Does 3 go into 4? No, and by go into, I mean divide into. No, then I take 4 times 2 is 8. Does 3 go into 8? No. What about 12? Yes, and that's how I find it. I take multiples of the bigger number, or the biggest one, until all the other denominators go into it, and that 12 on this one. Well, guess what? If I don't have any variables, can I have any restrictions here? Nope. So my restrictions here are none, or ain't none. All right? There's no restrictions, none. Then I multiply 12 times my first term. And if you want to put the 12 after it, it doesn't matter. 12 times my next term plus 12 times 1, okay? You can put the 12 before or after. When you multiply, the order doesn't matter when you multiply. So I need to remind myself, hey, wait a minute, I'm multiplying a whole number times a fraction. What is that 12 really over? It's really over 1. Again, I don't know of a case where you would ever answer over 1, but we got to remind ourselves that way this divides out and becomes a 4, and this is a 1. And look, if everything down here is a 1, you no longer have a fraction. That's the glory hallelujah moment, right? 4x equals 12 over 4 is 3. That becomes 3x because that's 1. So this is just 3x plus, nothing divides out here. 12 times 1 is 12. Excuse me. So, technically, I should have gotten this side over 12, this over 12, and this over 12, combine these two, and then set my numerators equal. See all those steps I just skipped? So, I eliminate those steps by multiplying everything by my LCD, and then all of a sudden, boom, I get this nice equation here that I know what to do with that no longer has fractions. All right? I probably can get some amens right here. So now, this is linear. I just say, okay, let me move this to the other side here, right? So this is going to be minus 3x on both sides. All right, I know some people say, just move it over and change the sign. Why do I do that? Because I'm subtracting it from both sides. That's why. It cancels over here. That goes to 0. That cancels. And this is x equals 12. And that's really nice because there's no coefficient to have to divide by here. So then x equals 12. That's my final answer. Now, I did box it, but look, I got to check my restrictions. Well, since I don't have any restrictions, then 12 is a good answer. So then 12 is my answer there. That one looks bad. 12 is my answer there, okay? So I have no restrictions. I got 12, so I can keep 12. If 12 were a restricted value, I'd have to throw 12 in the garbage. Couldn't use it. Sorry, 12. But here I can use 12. 12 works just fine. So that one didn't have any restrictions because guess what? There were no variables in the denominator. So actually that problem wasn't necessarily one of these because typically when we talk about rational equations, we are saying there's x's in the denominator at the bottom. So let's look at this one. Guess what? Now we have x's in the bottom right here, right? We've got one that's a 3, but we got x's in the bottom. So that means we have restrictions in this case. Can I factor any of these denominators? No, they're already factored. So for my LCD, I'm going to come out here because I got to find restrictions. Just an LCD, I got an x and a 3. So if I multiply them together, that's 3x. So then to find my restrictions, I'm going to kind of block this off. For my restrictions, I take my LCD 3x and I say it can't be 0. And if this over here were factored, like if it was times x plus 1, I would just have another x plus 1 can't be 0 over here, okay? And we'll see that as we go through these. So 3x can't be 0, divide by 3, and what can x not be? X cannot be 0. So my restriction here, x can be any number in the world it wants to be, but it cannot be 0. X cannot be 0, all right? So now I go back and say, guess what? I need to now multiply my LCD times all 3 of those terms, okay? So I'll do it a little different this time. I'll put the 5 over x, and then I'll put the 3x after it this time. It doesn't matter, okay? Plus 1/3 times 3x, okay? I'm going to put it in parentheses, equals 6 over x times what? 3x. So you can imagine as my LCD gets bigger, notice I wrote my LCD once, twice, 3 times here. If I have more terms and my LCD is 5, 2-term factors, then I'm writing stuff down for days. I might need to turn my paper sideways to make it fit. But you know what? One step gets rid of my fractions. That's what's glorious about it. So I'm going to remind myself, hey, guess what? This LCD is times a fraction. So is this one. So is this one. So all of them I need to remind myself are over what? 1. Anytime I multiply a whole number times a fraction, remind myself it's over 1. Because then I can say, hey, there's an x here and an x here. Because this is 3 times x, if that was 3 plus x, I couldn't do this. But 3 times x, they cross out, they divide out, they do not cancel. I know that your teacher was taught cancel. My teachers taught me cancel. Sometimes I say cancel because I grew up. See what happens. We, the math community, lied to everybody so long they even put it in the dictionary. If you look up old Merriam-Webster, he's going to tell you that dividing out common factors is part of the definition of cancel. That's actually not true anymore. I don't have a book under 30 years old in my office that says cancel. The only one in my office is one I had from high school that says it. Okay? So or the same book. It may not be the same exact textbook, but the same version. So then it's that old. So these become 1. So 5 times 3 is 15. Things cancel when they go to 0. Those things divide out and become 1. All right. So here the 3's divide out, and I'm left with plus 1 times x is x equals, here the x's divide out. 6 times 3 gives me what? 18. So 15 plus, see, look how glorious. That's so easy to do compared to this right here, right? Oh my gosh, I mean, that's a glory hallelujah moment, right? I mean, I just one step and boom, my fractions are gone, right? And this always works. I only do steps that always work, okay? So there's other ways you could try things here, whatever. Cross multiply is a big thing that people try, but it won't work on this problem. So have fun. Subtract 15. In fact, in my 20 plus years, I've never ever once taught cross multiply, because it works sometimes and doesn't work sometimes, and it's more difficult to figure out when it will and won't work. So back to this problem. Subtract 15 from both sides. This cancels because it goes to 0. So x equals 18 minus 15 is 3. How does that compare to my restricted values? It's not one of them, so that's a good answer. I keep it, 3. X equals 3. It's a good answer. Keep it. Boom. So these first two were not terribly long, but don't you worry. They can get much, much, much more intense. Don't you worry. So here, again, my LCD, I need to try to factor. Can I factor either one of my denominators right now? Can I factor this one? No. Can I factor this one? No. So then my LCD is going to have an x plus 3 and an x minus 1. And that's going to look like this, x plus 3 and x minus 1. So when I get over here for my restrictions, okay, then I just say x plus 3 can't be 0, and nor x minus 1 can't be 0. So I just take each one of these factors and set them equal, not equal to 0. Okay? I don't have to sit there and write the whole thing and all that. That's what's going to happen. Each one of those factors, each one of these things in my list can't be 0. So subtract 3, and the last one was just 3x. That's why I didn't bother talking about that there. X cannot be negative 3, and here add 1. So x cannot be 1. So my restricted values are negative 3 and 1. Don't forget to put the comma there, okay? And don't do this. I mean, some people write bad. That's 3 comma 1. No, it's not. That's 311, okay? Negative. So negative 3 comma 1. So that means I have 2 restricted values. That doesn't mean I'm going to get 2 answers. That just means I have 2 answers that cannot happen. So if I get either one of those answers, throw it in the garbage. If I get any other answer, I keep it, or answers, as long as it's not one of those 2 values. So now I take my LCD and I multiply it by both terms, okay? Because I only have one term on each side. So I'm going to take 7 over x plus 3, and I'm going to multiply it by my LCD. And then 5 over x minus 1, x plus 3. And let me say something again. I know I'm writing down a lot here, and I know I have people watching this. Oh, I can cross multiply. You know what? You can on this problem, but we couldn't on the one before. And I got students that try on all of them, I promise. Okay? I've been doing this again for over 2 decades, teaching. I tutored for probably close to a decade before that. So I've been doing math, helping people with math, teaching people math for 3+ decades. And cross multiply is something I made a decision never to teach before I ever got started. Because, again, it's harder to know when you can and when you can't than to actually do it. It's very easy to do, but that's why everybody tries it on every problem. So, anyway, if you teach that, I prefer you stop, because you and I know when to do it. But when you're teaching somebody who's trying to learn, that's the hard part they struggle with, is when I can and when I can't do it. So if you search your feelings, use the Jedi, the Force, you'll find out that I'm right. All right? So I wanted to be funny with Star Wars there for a minute. Okay? So I'm going to remind myself that this is over 1 and this is over 1. Okay? And these things cross out, and I'm left with 7 times x minus 1 equals, these things cross out, and I'm left with 5 times x plus 3. And that's because this is multiplied by this is multiplied by this. There's no pluses or minuses outside of parentheses. That's why I can cross those out. Same thing on the other side, the left-hand side. So look, again, this equation here is way simpler than that. Okay? And by the way, that's the same equation you get if you cross multiply, but I don't ever teach it that way. Okay? Because, again, students will try it on something else. Just go look back at your test you've given if you teach it. All right? So then here, and you've always wondered why, 7x minus 7 equals, distribute here, you get 5x plus 15. And then now this is linear, so I have to move things to one side. So I'm going to choose to move my 5x by subtracting it from both sides. Okay? When I do that, that cancels because it goes to 0, and I get 2x. And look, you don't have to do this, but I'm a fan of, hey, if I can save myself a step, if I cancel my x's over here, I need to cancel this thing over here, right? So how do I cancel that -7? I add it to both sides. So that gives me 22, and then I have a big equals in the middle. Now, I wrote that really far apart, so let me just come over here and say this is what it would have looked like if I'd have written it nice and neat and together. 2x equals 22. And then I do what? Divide both sides by 2, and these 2's divide out. They become 1s. They do not cancel, all right? They don't cancel. I know we were taught cancel. The definition is in the dictionary, but it's not right. It's not in any math book anymore. All right, what we do as math teachers, we just teach what we remember. We don't always read the book. We should. It's our book. We're using it. X equals 11, or we don't notice something like that. X equals 11. That's not one of my restricted values, so I can keep that number. So boom, there it is, 11. There it is, 11. So here, let's see, get my setup over here for my LCD. What's it going to look like? And my restrictions over here. So can I factor this one? Nope. So I already know x plus 1 is part of my LCD. Can I factor this one? Yep, I sure can. So let's go down here. It's difference of squares, right? 2 terms. You got an even power, a minus, and a perfect square. And sometimes we look at 1 and go, oh, 1's not a perfect square. Yes, it is. 1 times 1's 1, right? We just don't think about it. We get 4, right? 4 is 2 squared and 9 is 3 squared, but we forget 1 is 1 squared. 1's a perfect cube too. 1 times 1 times 1 is 1. So, but 1 is there, so that we get plus 1 and minus 1. So then x minus 1 needs to be added to my LCD, so it's x plus 1, x minus 1. And so then for my restrictions, x plus 1 can't be 0, nor x minus 1 can't be 0. And then solve each one of them. I get 1 for a can't be, and I get minus 1 for a can't be. So I'm going to write it as plus or minus 1. You can write -1, comma 1. That works, okay? But when it's the same number, positive and negative, we math teachers, some people call us lazy, but we are efficient, and we just write plus or minus. We write the 1 once. But you can only do that when it's the positive and negative of the same number. So now I'm going to take this and multiply it by both sides, all right? So I'm going to say 4 over x plus 1 times my LCD, x plus 1, x minus 1, equals 1. Look, you've already factored this. Write the factored form here. Don't redo. Don't work it again. X plus 1, x minus 1. And multiply that by your LCD. See how long this is already getting? That's a long step. It's a lot to write down. In fact, my students say, Mr. Guess, would you slow down when you write that? You stress me out. So I'm going to pause for a second, try not to stress you out. It's not my goal here. My goal is to help you understand. I want to change the world, change the math world. All right? I want to help you out here. So I multiplied everything by the LCD. I'm going to remind myself it's over 1. Over here, everything's multiplied together up here, so I can cross stuff out if it's the same. That's the same, so I'm left with 4 times x minus 1. Over here, x plus 1 divides out, x minus 1 divides out, and I'm left with just a 1 because all these become 1. So if I multiply a bunch of 1s over multiply a bunch of 1s, that gives me 1. Okay? That gives me 1. What did I do? So this is going to be equals 1. I mean, look how glorious this is compared to that. Hey, and here's your little secret. If you cross multiply that one, you make your life a whole lot more miserable. If you use this method, it takes care of some of that for you. All right? You just have a lot more factors to deal with up here if you cross multiply. Have fun with that. So here, 4x minus 4 equals 1. And then add 4. But again, it's harder to know when you can and when you can't. Here you can. Next one you can't. 4x equals 5. And then we're going to divide both sides by 4. So we get we get up here? X equals 5/4. Is that one of my restricted values? No, real close. 5/4 is not very far from 1, but it's not exactly 1. Now, I didn't give myself a lot of room for this, so bear with me as I try to fit this in here. And quite frankly, right there with 5/4, a slanted fraction is okay, but I will never write a slanted fraction. You won't catch me doing it. Not happening. So let's look at this one. Wait, I already changed my colors. So let's find the LCD, which this one is actually pretty easy to find. If you look at this, just check it out. Can I factor this one or this one? Nope. So guess what? X minus 2 is in my denominator. And remember, this 2 is over 1. So that's all that my LCD is. It's just X minus 2. So then for my restrictions, guess what? All I have to worry about is X minus 2 can't be 0. So I add 2 to both sides. And X can't be 2. It can be any number in the world, but it can't be 2. Oops. So now I'm going to multiply my LCD times this term, and this term. This problem, cross multiply, doesn't work. If you try it, it's going to be wrong. Don't do it. 2 over X minus 2 times X minus 2 equals X over X minus 2 times X minus 2 minus 2 times X minus 2. Don't forget that whole number gets multiplied by X minus 2 as well. And then I'm going to remind myself, this is times a fraction, so it's over what? Oops. It's over 1. This one is times a fraction, so it is also over 1. Do I put this one over 1? No, that's not a fraction. Don't put it over 1. It makes life more complicated. Don't do that. So here, guess what? This crosses out, and I'm left with 2 equals. This crosses out, and I'm left with X minus 2 times X minus 2. And this, my friends, is glorious. It's so much easier than that. Right? So much better. So I'm going to go ahead here and distribute my negative 2. So I get 2 equals X minus 2X. Why do I get plus 4? Because I have a negative times a negative, right? And here, look, I know that technically we need to simplify this before we move this over, but guess what? There's nothing else that goes with this term. So since the 2 is by itself, let's go ahead and move the 4 over there with it, okay? So I'm going to subtract 4 from both sides. And at the same time, I say, wait a minute, I need to combine those terms, right? So let's combine those terms at the same time. I'm doing 2 steps at once. That cancels. We get what? X minus 2X is negative X. And over here, 2 minus 4 is negative 2. And then I say, wait a minute, I don't want negative X. I need to get rid of that. So I do that by dividing by negative 1. Because what do I always do when I have a number times X? Don't I always divide by it? So I'm going to, you can multiply. You can do either one. I'm going to divide by it. So then negative 2 over negative 1 is 2, and that equals X. Now, do I keep that number? Look, 2 is a restriction. Wait a minute. I can't get 2, so I have to throw that in the garbage. I got to throw that in the garbage. So guess what? I don't have any answers because the only answer I got was restricted. That's what a restriction means. If I get that number, throw it in the garbage. Sorry, 2. But it's okay. 2's a number. It doesn't have feelings. It's okay. It's not like you and me. We have feelings. All right, so this is the last one of these we're going to do. It's a pretty big one. This is a big boy, as is the case typically when it's the last one. So we got an LCD here. We're going to try to find that, and then we're going to find our restrictions out here. So for my LCD, I already know I can't factor this one or this one. So I know I have X plus 3. That's not a 3. X plus 3 and X minus 2. But this I can factor, right? That's my list method. So let's factor it. Factors of 6 that subtract to give you 1. All right? So 1 and 6 or 2 and 3. The thing people try to do, they go, oh, that's got a 1 in it. No. 6 minus 1 is 5, but 3 minus 2, that works, doesn't it? And then the bigger number gets a plus is what that says. Bigger number 3 gets a plus, and since we say bigger, it's minus there. And also in my mind, I'm saying different because of that. Okay? So X plus 3 is already here, X minus 2, so that's great. That's great. We already have those two things in my LCD. So X plus 3 and X minus 2 is my LCD. So for my restrictions, X plus 3 can't be 0, nor X minus 2 can't be 0. So then I solve each one of them, and I get X cannot be 2, And I also get x cannot be negative 3. And I know a lot of y'all skip this step right here. Look, let me say it again. I've said it before. I'll say it again. You'll hear it on my videos over and over and over again, sometimes on the same one. Why are you watching this video? Not because you were sitting around going, hey, I'd like to watch math videos. Nobody does that. No, if it was bloopers or sports feats or funny cats or something, maybe so, but you don't want to watch math unless you have to take a class and take a test or something. So look, if you're taking a test, why not go through the process of showing that step so you don't miss it? Okay? You might get it right 90% of the time, but why miss it the other 10%? Get it right 100% of the time. Okay? Now, I know we make careless mistakes. We're humans, but that reduces your chances of careless mistakes. Okay? So here, I'm going to take and multiply this by every single term. There's 3 terms here, okay? So I'm going to have 6. This is going to be a long step, not a hard step, but a long step. And then x plus 3, x minus 2, minus 5 over x minus 2 times my LCD, x plus 3, x minus 2. And then equals, and don't look, that's a negative 20. Don't forget that's there. And then the other thing is, I didn't mark through this. Use your factored form right here. Don't go back and write down the other and have to refactor it. That's silly. Okay? So then this, and then times your LCD. So notice it took pretty much the whole board for me to write this one down. And I only had 3 terms with two two-term factors. But again, not a hard step, but a really long one. But guess what's going to happen? When I put everything over 1, I remind myself, hey, that's over 1, that's over 1, that's over 1, because they're all times fractions. Now, these things divide out, and I'm left with 6 times x minus 2. Minus 5, that's what this is. Minus 5, and what's left over here? Those divide out, and I'm left with x plus 3. Equals, that goes away, and that goes away, and I'm left with just this. Now, here's the kicker. Sometimes this negative sign is out here. So if this negative are out here, don't forget that whole thing is there, okay? It's not there on this problem, but I just want to point that out and say, hey, in fact, the book I teach out of, I got this one out of, or one like this out of the book like that. And then another one in the same book has this negative sign in the front right here. So that's what I'm saying. You got to be careful. All right, but here there's nothing in front of it, just the negative 20 there. So look at this red equation again. Glorious, 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 glorious. Okay? No more fractions. Distribute to 6. 6x minus 12. And then minus 5x minus 15 and equals negative 20. And then 6x minus 5x is x, and then minus 12 and minus 15 is minus 27 equals negative 20. And then I'm going to add 27 to both sides because the only thing on the other side is a number. That cancels. X equals, not negative. They're different signs. 27 is bigger. Positive 7. And you know what I didn't write down? Go back and write down my restricted values. Negative 3 and 2. I didn't put them in my box down here. But either way, I still have them. Is that one of my restricted values here? Nope. So guess what? There's my final answer. So my answer is 7. Having trouble writing a 7. My answer is 7 there. Okay? So I hope this helps you solve these. I know some of the things I do in this especially are a little bit unconventional, but that's how I do things. So, and I like to do things that always work. Always, always, always work.